So for this problem, I'm going to be answering part A. You have just come back from surfing and you want to hang up a wet bathing suit that's wet. You're hanging it on a wire going across your room. And all we know right now is that we have a mass of 3 kilograms. And you know that the tension exerted on the wire is 60 newtons. So the first part of the question asks to draw a picture of free body diagram to indicate the forces acting on this section of the wire. How much does the wire sag? So first off, draw our free body diagram. You have your 3 kilogram suit, and because the tension is being split between 2 wires, it's T equals 30 newtons, and then over here, you have your mass gravity pulling down, and then your 2 tensions going up at angles. So we can further draw it in a triangle here, knowing that it's a horizontal force we're dealing with, so we're going to use sine theta. And just like you can use it for T of x, you can use it for T of y, for the tension to find F of y. So 2ty, it makes sense because we've got 2 wires, so 30 times 2 is 60. And you have your MAy over here, 3 kilograms times 9.8 per meter second squared. And we're just going to plug these values in. So we plug the values in, and we want to get the angle. So we're going to divide this side by 60 newtons and divide this side by 60 newtons. And we get sine theta equals 0.49. So once you get this, that's not the angle. You've got to take the inverse sine of it and solve it using your calculator. And you'll get theta equals 29.34.
As the bathing suit dries out and lowers the mass, the wire begins to rise again and become more horizontal. The same tension in the wire, what mass would be required to make the wire perfectly horizontal with no sag at all? So we know that horizontal is equal to the angle of being 0. And we know that the force of gravity is equal to the tension times the sine of the angle. So, and then we know that gravity and tension are constant because it says with the same tension in the wire, and gravity is constant because we're assuming that gravity is constant. So this makes this whole equation a function of mass and mass by the angle. And so I took the limit as the angle goes to 0. So then we know that the sine of 0 equals 0. So then, because everything else is a constant, they wouldn't affect the equation at all. So then 0 times 60 newtons over 9.8 meters per second squared is equal to 0 kilograms. We know that it is equal to kilograms because newtons equals to kilogram. Newtons has units of kilograms times meters per second squared. And then since we divided newtons by meters per second squared, the meters per second squared cancel out and you get kilograms. So then the units work out